So as we dig deeper into respiratory physiology, what we're ultimately going to see is they have their own languages with lots of different ways to express them. So we're going to start with just defining some of the values that you're going to see a lot, and then we'll define them in the next slide. So one thing that you'll see very often is the use of V. So V stands for volume, or you can see it in another way, V dot. When you see a dot over the top, what they usually mean is volume per unit of time, and that time is almost always a single minute. Okay? So within that, you can have VT, which is tidal volume, VD, which is the volume of dead space, VA, which is alveolar volume, VI, which is inspiratory volume, or VE, which is expiratory volume. And again, you can see these with or without dots. If you see a dot, that means time. So if we put some of those abbreviations into practice, here's what we look at. So in pulmonary ventilation, when we talk about the amount of air moved in or out of the lungs, we just call that volume. Right? The amount of air. Tidal volume is equal to the amount of air moved per breath. We also have breathing frequency, which is simply the number of breaths per minute. Then we have alveolar ventilation, which is again the volume of air that reaches the respiratory zone. Respiratory zone includes the respiratory bronchioles and alveoli, hence the term alveolar ventilation, where gas exchange takes place. Dead space ventilation, or VD, is the volume of the air that remains in the conducting zone. Again, no exchange of oxygen. These are just the passageways of getting volume down. So this includes the trachea, the bronchi, bronchioles, in order to hold air, right? Because when you breathe out, you don't completely empty all of the air in your conducting zone. There is an amount left, which is called dead space ventilation. Dead space because there's no function of this air besides being there. We get no ventilation from it. So therefore, the volume of air that we breathe per minute here, as seen as V, or more appropriately V dot, is equal to our tidal volume multiplied by our breathing frequency. Right? How much you breathe in by how many times you breathe per minute gives us our tidal volume. We can also say our pulmonary ventilation is equal to the volume, the alveolar ventilation plus the dead space, right? The amount of air that makes it to the respiratory zone and the conducting zone will give us the volume of air moved in and out of the lungs per minute.